Okay, this lesson is about circles and specifically circle equations. Again, this is something that we haven't covered, but it's not actually too bad, and it's something that very likely could show up on the ACT or the MCA. All right, so there's going to be this special equation for a circle, and so I just thought to kind of review a warm-up. When you have a straight line, there's also equations for that. So see if you can remember, like, what is the equation for a straight line. So pause the video, give this a shot, and then I'll be back with you. All right, so if you forgot, the most basic form for equation of a line is mx plus b, called slope-intercept form. And to write the equation, this line is made up of a whole bunch of little points, xy points, and so the equation, you can just fill in those two values. So our y-intercept is about negative 1.5, so that's going to be b in this case. And then the slope, you kind of have to pick two whole number points, which maybe this is a little bit of a tough example because there's not a lot of great whole number points here to pick from. See if we can find one. This one's not too bad here, right? So the slope, we might not be able to get exact because my picture's not super great, but if we assume those are about whole number points, we would be going up 3 and right 4, and so we'd have a rise over run, so you do the up or down on top, so it'd be 3/4 x minus 1.5. That would be roughly the equation for that blue line. Okay, so much like you have a line, there's an equation for a circle. All right, so taking notes today, this would be the big thing to get down. It's just this. This is the equation for a circle, and the circle is made up of xy points, much like a line. So that's going to be our two variables again, x and y. And then the other part you fill in, just like you fill in the slope and the y-intercept for a line. For a circle, the h and k is going to represent the center of the circle, and then the r is going to represent the radius. So in the formula, you actually have the radius squared on the right-hand side. Right, so looking at my picture here, if I want to do the equation for that circle, it would just be x minus 1. So this is h, that's k, that's my center. So it'd be x minus 1 squared plus, and then it would be y minus negative 3 squared for the y-coordinate. And then the radius we could just sort of count. So we could connect from the center out to the side and just count. That's 1, 2, 3, 4, 5 units. So this side would just be 5 squared. Okay, and oftentimes they'll clean this up a little bit so that the minus negative write it as a plus, y plus 3 quantity squared, and then on this side you'll have r squared of 25. So the equation for the circle shown is this guy. All right, so one more for you to try here. So here's your little formula, and we've got center and radius 4, so just plug them in and see if you can get the right equation. Hopefully you got a chance to try it. So here are our h and k points, and here is our r radius, and we just got to plug them in. So it's going to be x minus 2 squared plus y, and then we're going to go minus negative 5, so that's going to become a plus 5 squared equals 4 squared, so this is radius squared, so it's just 16 on that side. And that's it. That's your formula. Okay, so slightly different style of question. We're still writing the equation, so it's the same formula from the previous screen. Maybe I'll grab it here for you in a second. Actually, I can go back and grab it real quick for you. And then we just got to translate it. So I'm going to see if you can figure out, here's your equation again, right? And then if we had to translate it up 3 left 2, what would the equation look like? Okay, and so this is our original one. So if it helps you sketch it out, right? Hopefully you got a chance to try it. So here we go. So basically this original circle, I know the radius is 2 and it would have a center right on 0, 0. Okay, so I'm going to draw this as best I can, but that's my original circle. And then I want to translate it up 3 units. So it's going to be up 3 and left 2. So my new circle is going to have the same radius of 2, and then just translate it around. Okay, so basically radius of the new circle is 2. And then the center, now that we shifted up and left should be -2 for x and 3 for y. So now it's just like the last one where we plug it in, right? So it's going to be x minus -2, it's going to become a plus. That's our center, the x of the center, and then the k value is the y coordinate of the center, and then we have radius squared, so that's just 2 squared, which is 4. I guess I should have pointed out here originally that I knew my radius was 2 because this 4 represents radius squared, so I knew my radius right away was 2. Sorry, I should have pointed that out in the beginning. All right, but here's our equation after the translation. Okay, and all these questions are just slight variations of the same thing. So again, I'd pause this one, see if you can make some sense of it. All right, so we're going to start by identifying the center and the radius. So the center point is, these grids are actually going by 2. So the center point would be x2 and y0. And then the radius we can just count. So each one of these is 2, so it would go 2, 4. So radius would just be 4. And then you just plug it in. So x minus 2 quantity squared plus y minus 0 squared equals the radius of 4 squared. And again, if we clean it up a little bit, x minus 2 squared plus y squared. So y minus 0 is just y, and then 4 squared is 16. Okay, and it's tempting for students here to want to like make this into 2 and FOIL it out or something, but this is just how the equation of a circle looks, so just leave it in that form. Okay, again, just a slightly different style of question. This time it's asking you to create the graph. You have the equation, create the graph. Take a minute, see if you can make some sense of it, and then on pause and check your answer. Okay, so this is h and k, and if the original equation is x minus h, and so if we're minusing h and we got a plus 2 here, that means that h must have been -2. It must have been minus -2 to get the plus 2. And then the k is just a regular 3 because we're doing y minus k, and so k is just 3 here. Okay, and then over here, radius squared is 36, which means radius must be 6. Okay, so then just to draw this, I'm going to plot the point -2 and 3 for my center. And then this is struggle bus for me a little bit because we got to draw the radius of 6. So I kind of go out 6 in each direction. Actually, I got it right. 1, 2, 3, 4, 5, 6. Okay, and then go out 6 this way. And then 6 down. And then best I can draw circles. This is going to be brutal on my little pad here, but draw the circle. Oh, that's rough. But it should have went right through that point there, right? So that would be the graph of our circle. Okay, so last two are getting a little more tricky, and they're getting more towards what you might see on the ACT or the MCA. This one we got to use the distance formula on. So we're going to write the equation of a circle. So here's our formula again, and we don't, well actually we know, let's see, that has a center at the origin. Okay, so we actually know what h and k is going to be. H and k are just going to be 0, 0, because our center is at the origin. And then it passes through the point 3 and 2, so visually it must pass through that point. So we could attempt to draw. Maybe I can draw with my circle tool here. Try it one more time. Ah, look at that. So there's my circle. Right, it has center 0, 0, and it goes through that point. So to do the equation, I've already got h and k. Boom, there's h, there's k. But what I don't have is the radius. Right, so I've got to figure out the radius somehow. Okay, and there'd be a couple ways to do this. One would actually be you could draw in a right triangle. Can't do that very well with my little pen here, but you could make this a right triangle, and then do the Pythagorean theorem to get this radius r. Or I think this would be a good review for the for the test, both the ACT and the MCA, is you can use the distance formula to find the distance between any 2 points. So the coordinates of these points that are on here currently are 0, 0. That's the center. Sorry, my pad is struggling here. 0, 0. And then this point was 3 and -2. And actually, just realized I graphed that wrong. It should have been down here. 3 and -2. Right, but at any rate, I think it actually doesn't change the question. Sorry, I messed up on the graph there. But basically, I got to find the distance between those 2 points, like 0, 0, and then 3 and -2. So again, you could do the Pythagorean theorem, or I could just do my little distance formula using my x and y coordinates that's shown here. Right, so just to review, because I do think it's good to know this distance formula, because you might use it, and again, it's used to find the distance between any 2 points. So we're going to find this distance right there, right, using the 2 points. So I tried to clean up my picture here a little bit, but hopefully we can see that's the 2 points we're trying to find the distance formula for, because that's going to be our radius. Okay, so distance formula, you minus the 2 x coordinates in any order. It really doesn't matter which one's x little 1 and which one's x little 2. So here's my 2 x coordinates. So I'm just going to do 3 minus 0 squared. And then the y coordinates, again, the order really doesn't matter, because once you square it, it'll become positive. So if we just do -2 minus 0 and squared, and hopefully you remember doing this formula at some point last year. So this is now 3 squared plus -2 squared. Okay, and we're going to square them next, so it'd be 9 plus 4. And then if we keep going, so we're going to have the square root of 13. And I'm actually just going to leave it that way, right? That's going to be my distance or my radius value, right? So at this point, we can actually complete our equation. So here's h and k, 0 and 0. And then this is our radius, so we just have to square it there. So the formula would be x minus 0 squared plus y minus 0 squared equals the radius, we're at 13 squared. Okay, and that will clean up to x squared plus y squared equals 13. Okay, so a little bit goofy one, you had to use the distance formula to find the radius. Okay, last one. I found this one online, like a sample ACT one with a circle, so it's pretty tricky, but pause this video and see if you can make any sense of this. All right, and then I'll go through the answer with you. All right, so on this one, we need to find the area of the circle, right? So the area of circle is just pi times radius squared. So really, if I could find the radius, I could just square it times pi, and then I would have my answer. So this question is essentially, can I find this radius? Okay, and much like the last one, I can do the distance formula, but the only tricky part is I need the coordinates of this point right here. All right, and so the way we do that is this point is from that equation, and so I know the x coordinate is 2, but to find the y coordinate, I have to plug it in. So this is my little equation. If I do x2, put it in, then y must be 1.5 squared, which is 2.25. Okay, so sorry that didn't show up super good there. Now to find the distance, I'm going to use the same formula as the last one. So it's going to be minus the x coordinates, so it's 3 minus 2 squared, plus minus the y coordinates, so it'd be 2.25 minus 1 squared. And again, you can do them in any order, it won't really matter. I'm going to kind of speed through this because I'm running a little bit low on time. So I'd have 1 squared plus 1.15 squared. Okay, so sorry I did whip through the distance formula steps there, but you'll get the distance of 1.6. That means our radius is 1.6, and that's pretty much it. So now we just do pi radius squared. So it's pi times 1.6 squared, and that will get you to 2.56 times pi. Okay, Next up is the practice ACT questions.